Class, today we are going to be doing our final video for the Unit 1 exam. And the primary way that we're going to do this, I don't have a printout like I do with the lecture notes. What I do for my exam review is go through that full review exam, the optional one that's in my math lab. So if you want to follow along, basically I'm not going to be doing all the problems. We're going to be talking about how to use it to study, and we'll be doing some of the problems. I feel like I've already spent, several hours, working all the problems for this unit. So, I'll leave you to do more if you want. But if you want to follow along, get into Math Lab, open up your full review. It will be, your numbers will be different, but the questions will be the same. And so that's kind of what I'm really focusing on a little bit more on here today is more big picture, how to study for the exam, how to use the quiz, and that sort of stuff. All right. What else? Just general stuff. Let's look right quick at what is going to be on the exam. Like I said, hopefully by now you've been taking your quizzes, like the skill check quizzes, multiple times. Seeing what you miss in the, after you've done the homework, and then kind of do a feedback loop and go in and like restudy stuff. That's the whole purpose of these quizzes. So hopefully you're taking advantage of that. So what is going to be on this test? Well, all my exams are usually around 25 questions. Some of the later ones, I think like test 3 is usually around 20 because those questions get to be a little longer. But this is, there's some shorter problems here. There's a few longer ones, so it's going to be around 25 questions. And so what are the key sections for this test? What do you have to be able to do if you want to pass the test? Well, there's 3 main topics. All right, so main topic number 1 is R5 factor. All right, you got to be able to factor, and you got to be able to factor every single one of those techniques. So not only do you have to know how to use them, you have to know when to use them. That R7, so a lot of you did that for extra credit on the homework. If you did the R7 homework, if you completed that, I am giving out 5 points bonus on the test. That's the reason I'm doing that is for my in-person class. We lost a week due to all the icy roads, so I cut out R7 for them, and it just makes my life easier if the tests are the same. So that's not going to be on the test, but if you did it, you are getting bonus points. The other big topic is 1-1, solving linear equations. There is a lot of, there's messy linear equations with like distribution and simplifying to do. There are equations with fractions. I guarantee you're going to have to clear the denominator for one of these. We did proportions in there. So know how to do proportion, and formulas. Be able to deal with formulas, both like here's numbers to plug in, and if you don't have numbers to plug in. Formulas is often some of the more missed problems on that. But those are 2 to 3 big ones, because we're going to be doing, this stuff we're going to be doing all semester. And then the third big one is not inequalities. It is the solving quadratic equations. All right. So you got to know how to solve by factoring, solve by square root property, and definitely know how to solve by the quadratic formula. Right. And yes, you do have to have the quadratic formula memorized. Right. This is the only formula that you need to know for this test. So I don't think it's asking too much that you have that memorized. And I'll tell you this on when I tell every single class before a test formulas. If you're worried about memorizing your formula or like not having the formulas, once you get through, like you're doing an honor lock, you have to do like go through all that process, like show your blank paper that you're gonna be doing your work on. Once you get all that done, before you start the first question, data dump this on your scrap paper. Right? You can't write it before because your page has to be blank. Right? But whether you're testing in the Arc Center or you're testing online, like before you do your first problem, data dump your quadratic formulas. That way you'll have it later when you need it. And so those are the big three: factoring, solving linear equations, solving quadratic equations. So those are probably about, I don't know, 2/3 of the test, maybe. Like each one of these is going to have probably about 5 questions per section. Yeah, and that's 15 questions out of 25. So all these other sections are going to have like 2, maybe 3 problems per section. Okay, so the polynomial operations, that's like the degree and like being able to FOIL, being able to simplify like or combine like terms, roots and radicals, like simplifying square roots, with or without variables in them, maybe like adding square roots and multiplying square roots, that sort of thing. Complex numbers, know how to simplify radicals with negatives on the inside, so you get that I answer, and FOIL them, and then be 1, maybe 2 equations with some square roots. And then the test will end with solving inequalities. This was circled from before when I was doing the video, but if you can solve equations, linear equations, you can solve inequalities. Most of the mistakes that are made with inequalities is in how to present the answer, and then like forgetting to, if you divide by negative at the end, to flip. So there might be 3 questions on there, but like I said, the 3 big topics, if you know that you have any weakness in factoring, linear equations, or quadratic equations, that's what you should be spending the bulk of your time on. All right. So I put out a like how to study video, but I want to kind of real briefly talk about that again. And so if all you've done on your quizzes is like take them once and you treated them like an extended homework set, you have missed out on a big part of how to study for this exam. So I'll say it before and I'll say it again. The way I write the exam is I write all the skill check quizzes first. And then when I start writing the exam, I'll go to each skill check quiz and start pulling questions. Somewhere between 80 to 95% of the test questions come directly from the quizzes, which the quizzes questions come directly from the homework, but it narrows it down. And then I do take a few other homework questions to kind of fill in the gaps here and there. But most of all of these the test questions, if you've been doing your skill check quizzes as many exams and taking them more than once, they should all feel familiar. And to help with that is now that once you do 1.5, you'll have done the last homework set. Okay. And the last skill checks 1.4, 1.5. So there's a mini review. Notice it does say required, and then there's a full length review, which is optional. All right. And so everybody has to do that mini review. I've mentioned this, I may mention this before, but I'll mention again. Where these come from is once I write the exam, I make a copy of it, and then I start adding in extra questions. So like if there are, say, 5 factoring problems on the exam from R5, then on the full review, there's probably 10. I'm not going to give you the exact exam because I want to give you a little bit of variety, because at this point, you're college level students, so you're expected to be able to have to be a little bit flexible on stuff like this. But there's nothing on the exam that's not in the full review. Now, the full reviews, these are, like I said, these are about twice length of the exam. These are like somewhere between 45, 50 questions. I don't expect people to get those finished all at once. And depending on how comfortable with the material, I don't expect you to do all the problems, and we'll talk about it as we go through it. But it's a good way to review for the exam, and we'll talk about that once we get into it. Everybody has to do the mini review. So that way you're doing at least one test, like mini tests. I really would encourage you to give yourself like 30 minutes, sit down, take this mini review just like a test. Don't ask for help. Don't, whether it be person or AI or photo math or anything like that. Don't look at your notes, nothing. Just your calculator, and scrap paper. And then if you give yourself 30 minutes, because it's, like I said, it's about half length of the exam, and then check yourself, and then what you miss on the mini review, your mindset should be, well, that's what I'm going to miss on the test, unless I figure out why I miss it on the mini review. Now, you're not going to see every single problem on the test if all you do is the mini review. So they're like, like I said, if there's 5 factoring problems on the actual exam, when they do the mini review, it might, like the first factoring problem might be GCF or factored by grouping, like random. And then there'll be a second factoring problem, like probably like a trinomial or difference of squares. And so if you take it multiple times, you like randomly pick those. But basically it's like one question of each type. So so that, like I said, at least that way you have a kind of an idea of if you're ready for the full exam or the actual exam or not. All right. And I have 50 attempts there. I've never had anybody take more than like usually like 2 or 3 or 4 or 5, depending on like how much you've been using the quizzes before then. But I just put 50 on there to let you know that you can retake it. And like once you get a decent grade, like if there's still like one topic or 2 topics that you're struggling with, then you can take these quizzes and like skip everything except those 1 or 2 topics and not care about the grade because only highest grade counts. All right. Feel like I'm repeating myself with how to use the quizzes, but I think it's worth repeating. All right. And again, this is not just me as a teacher saying this. I was a math major. I took, oh Lord, I think I had over 50 hours of math classes for my bachelor's. And the only reason I could get that many legally is some of them were cross listed with like computer science or statistics. So I did a lot of figuring out how to study for math exams. And this is even if there was no quizzes in provided by the instructor, then I kind of figured out my own quizzes. Oh, and by the way, now that I'm looking at this, um, something's happening here because these are. Oh no, never mind. So they start to say these are past due, so something's happening. They are supposed to be past due, but notice that even the ones that are past due, you can still click on them and get into them. So I thought something was off, but it's not. Oh, and by the way, if you are retaking quizzes, if you wanted to review them before you take them, if you go to your student gradebook in Math Lab, let's see, have I taken the default is the past 2 weeks. Let me see if I've taken one change course to date. Have I taken a quiz? Well, I haven't taken a quiz for my student account in this class, but you notice where that review is. Same with the homework. So if you want to go back and review a quiz before you retake it, then you need to go into your grade book and review it from the grade book. And once you get into the grade book, like when you click on the quiz, that it'll have the right answer, and then if you missed it, there'll be a red triangle up there, and you click on the answer box, and it'll show you your answer. But that's how you review your old quizzes, is going to the student grade book in my math lab. And like I said, you most likely have to change look the entire course to date instead of the past 2 weeks. All right, let's get into the full review. Exam 1, not exam 2. All right, so here's what I would recommend doing this full review. First, I would take the mini review and then see what I do and then like focus on those problems. But if you want to like formally study, you can do the full review first. It just kind of works what works best for you. But my recommendation for the first time you look at this full review is put your pencil down. Right? Don't have the mindset that you're going to work every single problem. Right? Because at this point you've done hours and hours worth of homework. So we're now focusing on test skills. And one of the most common feedbacks I get from students on tests is that they can do it in the homework, but they don't know how to start it on the test. And so part of that is because you don't study how to start the problems, right? Because we don't teach you how to do that, right? So that's what I use the full review for, is open it up, put your pencil down, read the instructions, and ask yourself, do I know how to start the problem? Okay. If you do, and you feel fairly confident you get the right answer, then go on to the next one. Don't work the problem, just move on. If you look at it and you think you know how to start it, and you're kind of iffy, or if you don't know if you know how to work it, then go ahead and work it, see if you get the right answer. Okay. And if not, Don't study it right then and there. Make a note to yourself that I need to go back and study this question because I kind of got lost in the process, maybe. But if you look at it and don't know how to start it, then again, keep a on your. Hopefully, you have a homework folder. Say number one, I did not know how to start the problem, right? And so that way, after you go through all these problems, then you can see, spend more time on what you don't know how to start. Right. And then the ones that you knew how to start, but kind of, couldn't quite get to the right answer, those you don't have to spend as much time on. But you really need to know, like, do you understand the instructions? Do you know how to start? So for this one, and this is how I like to start. The test is in order that we covered the material. And I always kind of like to start my test with sort of a warm-up question. And so this is a perfect warm-up question for me. The polynomial, 2x to the fifth and all that is of degree blank, and the leading coefficient is blank. Okay. So hopefully by now you're comfortable with the fact that the leading coefficient, or sorry, the degree is 5 because that's the largest exponent. If this is not in descending order, watch out for that. And then the leading coefficient is whatever gives the coefficient on the term that we get to the degree. So if it's in descending order, the degree and the leading coefficient both come from the first term. Okay. Let's say, for example, though, this was minus 3x to the 10th instead of to the 4th, then 10 would be the degree, and then negative 3 would be the leading coefficient. So if it's not in descending order, you may want to put it in descending order. So that's all that is. All right. And so, like I said, there's like 2 questions there for degree. So that's what I said. The full review. Yes. Oh, see what's happening now is it's not letting me finish, which means that I have to change settings on this. So I'm gonna pause right quick, fix the settings, and then we'll restart. All right, so I had to fix a setting on this for review so you could. There was a save for later option that would let you like save it and come back to it, but unfortunately that doesn't let you like skip problems, which you really need to be able to do when you're using it to study. So I fixed that. And so if when you're doing that full review, if you don't have time to go through all of it, don't submit it. Just go up here in the upper right and X out of it. Not necessarily Math Lab, just X out of it. And then when you're ready to come back in, just open it up and you'll be able to continue. All right, so so here's a good question. So multiply the given polynomials, express your answer as a single polynomial in standard form. So what do we do with 3x minus 7 in parentheses squared? This would make for an excellent test question. Which, if you're not watching this video, then you don't get that little tidbit. All right, so how do we start? Okay. So I know it's, there's something that we addressed back in the R4 homework, but that was what, 3 weeks ago now, and there was a big snowstorm in between there, or ice storm. So how do we start the problem? That's the key in this problem. Most common mistake students make is just squaring each term. But we can't do that because it's a binomial. So what we have to do, the very first step is write this out twice. So it's 3x minus 7 times 3x minus 7. Then it's a FOIL problem. FOIL is something that students tend to like. So I'm going to go through that pretty quick. We get 9x squared minus 21x minus 21x plus 49. And then once you FOIL, then you combine like terms. Be careful of this. Another common mistake, sometimes students will see the 21s and cancel them out, particularly after we've done like difference of squares. But the signs have to be different for those to cancel out. Right? So they're just minus 20, minus 21 minus 21 is minus 42. Get 9x squared minus 42x plus 40. So this is one of those problems that if you kind of think you know how to start it, but you're not for sure, then go ahead and do it and then see if you get the right answer. And if not, then make a note to yourself that you need to go back and look at that. Okay. Okay, so now let's go back to So now we're into factoring. Like I said, R4 just kind of warm up most of these sections, and I have a couple questions. But R5, the factoring, is one of the more the bigger ones. And I'll give you a hint for those you watching the video. Like I said, I write the test in order that we cover it. Well, when we did factoring, we started with GCF. We did factor by grouping. Then we did our trinomials with reverse FOIL and AC method. We did difference of squares, and then we did like the messy ones that had like difference of squares and trinomial, or a GCF and a trinomial. All right, so that's what the test is going to look like as well. Here's where, if you're reading the instructions, as you've been doing the homework and the quizzes, that's going to give you hints on how to get started. So one, it says factor. Okay, so we know our answer is going to be something times something. Now, when it says factor out a -1, if the leading coefficient is negative, this is where if you've kind of been paying attention, is that applicable to this problem? Well, no, because the leading coefficient is a +3, so we don't have to worry about that. If that had been a -3, then our GCF would also be negative. But since it's not negative, then this is, what technique do you use? That's the other thing you have to know on the test is it a GCF? Well, it looks kind of messy, so that tells me it's a GCF problem. And then there's a 3 in all of those. They all have an X, they all have a Y. So this is definitely a GCF problem. Now, it's a trinomial. Could it be a GCF and a trinomial? Well, if this is the first factoring problem on the test, then no. I'm going to save the messier ones until after you've done a few. All right. Do we want to do this one? Yeah, let's do this one real quick. Again, yours, if you're following along in your full review, number is gonna be slightly different. But notice that it's talking about a leading coefficient. And so that's, even though they don't say specifically, factor out the GCF, they're giving you a hint, that we're dealing with, that's the C of GCF, right? And on the other thing I want to mention before I get here, a lot of these factoring questions have like, what's the answer, or B is prime. In the homework, there was, particularly if it was a sum of squares, there might have been one or two that were prime in the homework. I will not give you a prime factoring problem on the test. Okay? I think the factoring is more than enough of an issue. I'm not going to throw one that's prime at you. So if you say it's prime, know that you're missing the problem. And MATLAB is going to count it 100% wrong. Right? If you want partial credit on this is where you have to be writing out write out as many steps you can, even if you don't do it on the homework, write it for the test. And then when you get done, if you're taking this at home, then after you close out Honor Lock, take pictures. First of all, make sure your name's on your page, and please number your pages. So that way, because what I do is often is I print them out. And so that just helps me keep track of everything if your name's on it and it's numbered. But the way I grade your test, if you email me pictures of your work, is I will open up your test and any problem you miss, I will look for that work on your test and then see if you gained partial credit. So a lot of times with these factoring problems, even if you can't get it at the end, if you're going through the process, a lot of times that can be like half credit, right? Or if you just misadded or missed a negative, that might be like 1 point off, right? But if you don't give me your work, then you get no credit when you miss a problem. Okay. All right. So let's work through this one right quick. So there's definitely GCF. So there's 3 goes into all of them. And if you remember for the variables, then if they all have that variable, then you go with the smallest exponent. So these two have 1x, this one has 2, but they all have 1x. And then they all have a y. And the lowest exponent is 1, so it's 3xy. So now we can go to our answer. So 3xy, our GCF is half of it. You don't have to put it in parentheses. Normally we don't put the GCF in parentheses. I wish that was the practice, but how do you get the rest of the answer? Well, then you have to divide every term by the GCF. If you need to go through and actually write out that division, then by all means do so, right? If you're a little iffy on something, you're more likely to make mistakes if you're doing it in your head, especially on a test. Yeah. I think I've talked about this before, but I kind of, instead of writing out the division, I use the subtraction a little bit different. And so, 3 divided by 3 is 1. And then I need 2 x's. I have 1 x. I need 1 more. And then I need 1 y. I have 1 y, so I don't need any more y's. Or if you're doing it this way, 3 divided by 3 is 1. Y divided by y is 1. And then x squared divided by x is 2 minus 1, giving me x to the first. That's kind of how I do my division. And so I see like what more do we need versus like doing the division. It's just a different way to look at the same thing. So the middle term, -6 divided by 3 is -2. I need an x, I have an x, so though I don't need more, I need 2 y's, I have 1, I need 1 more. And then 9xy divided by 3xy, 9 divided by 3 is 3, and then x divided by x, y divided by y cancel out. So we're good. Now this is a trinomial, and there will be at least one problem on the test where you have to factor it twice, like do a GCF and then trinomial, or a GCF and difference of squares. But when I look at this, to do that, this needs to be x squared, or this is like x cubed, is x to the first or x cubed or x to the fifth. If it's a high exponent, then it's not going to factor. Our trinomials, all the trinomials we factored were x squareds or y squareds or whatever. Right. So that's kind of what you look for if you need to do it again. But also because this is the first factoring problem, I'm not going to throw the messiest factoring at you up front. Right, but this is kind of like showing work. And so like if you made an arithmetic mistake, then you can get, like this is a 4 point or 5 point problem. And if you said like +2 instead of -2, then I'd probably take off 1 point. Right. But if you don't turn any work, then to me that says you don't care about the partial credit enough to send me your work. And if you don't care about getting partial credit possibility, then why should I, right? So I shouldn't be the one that cares more about your grade than you do. So I want that work. So let's go back to the test, the quiz. All right, so that's, now notice that says factor by grouping. So again, if you're slowing down and reading the instructions, very often MATLAB's going to give you hints. And so this is a pretty basic factor by grouping. So hopefully, you pair up the first 2, look for a GCF, pair up the last 2, get a GCF. And then once you do that, if the parentheses are the same, then what's inside is half your answer, what's outside is the other half. So make sure you can do your factor by grouping. And then we get into trinomials. And so, when you're doing trinomials, well, first of all, there is no GCF, right? Because there's no number in some of them. They don't all have X. That's either reverse FOIL or AC method. Okay. I do not care which technique you use. Whichever one works for you is the one I want you to use. The thing with factoring on the test with the trinomials very often is people get the wrong signs. And so just a quick review on the binomials, what are the signs going to be once you put them out there? Well, hopefully you're not saying minus plus. If you are, then you're going to need to review that a little bit. But remember, when you're looking for the signs of these trinomials, always look at the constant first. So that's a plus 28. So the only way that you can multiply two numbers, you get a positive, is with the same sign. Either need to be plus plus or minus minus. And so since that's a minus 11, then it's going to be minus minus. Good. And if you get those signs wrong, you can waste a ton of time on factoring, or factoring trinomials specifically. Because if your signs are wrong, your numbers are never going to be right. And this is where it's important, when you're factoring on the test, if you get something that doesn't work, don't erase it. Like put an X through it and then come down and try your next attempt or try the rest of your work. Because what you're erasing is one, that's work that could get you partial credit. And two, I've seen students try like the same thing over and over again after they've erased it, right? So don't erase wrong work on the test, just put an X through it and move on. Okay, because that's part of what I'd look for on your process when I'm grading for partial credit. Okay. So if we're going to do this reverse, and I would do reverse FOIL because there's a 1 in front of the X squared. So for me, reverse FOIL makes more sense. So if you want to show work, we're factoring X squared and we're factoring 28. Well, X squared is either X and X. 28 is 1 and 28. 2 and 14. 3 doesn't work. 4 and 7. And if you're going in order, 5 doesn't go into it, 6 doesn't go into it, 7 does. So those are all the possibilities. So if you haven't done your factoring in a while, definitely go back and look at it. Okay, so to get X squared, you have to have X and X. So now we're making our educated guess. And so this is where the signs come in. So to get that positive 28 and a negative 11, we need negative times negative to get the positive. And now what's going to add to give me minus 11? Minus 4, minus 7. And being a test, go ahead and check it, FOIL it out to check. Whether or not you do that might depend on how comfortable you are with your factoring, but there's minus 4, minus 7 is minus 11. That gives me plus 28. Sometimes I'll have students that after they FOIL it, they'll get the original answer and they'll put that answer back in MATLAB. So MATLAB would obviously count that wrong because they want the factoring problem. But if you've got that on your paper and you wrote this answer instead, I will go back and give you, at most, I take off 1 point. But that's sometimes these problems, there's not a lot of work to show, but even a little bit gives me something to check for partial credit. All right. So that's sort of a basic trinomial. And after we get out of this test, most of the trinomials back to the semester are more like that. They're not as messy. There's another basic trinomial, another basic trinomial. Again, don't answer prime. If you are going to answer prime, make sure you have work on your paper. Because I can tell you right now, if you just guess prime with no work, you're not getting any partial credit there because all of these will factor. All right, let's do number 11 with AC method. We're factoring 5x squared plus 19x minus 4. Now, once there's a number in front of that squared term, often the AC method, like if you're really comfortable with your foiling, then you could still do this reverse FOIL, but this is where more people tend to prefer the AC method. Again, I don't care which method you use, as long as it's working for you. And so remember, with the AC method, the generic trinomial, and this is a quadratic equation, we make that equal to 0, but the generic trinomial is ax squared plus bx plus c. So the AC gets its name because we're multiplying the first and last terms. So 5x squared times -4 is minus 20x squared. I'm not going to do the minus now because the minus will kind of take care of itself later. I'm just aware, I am aware that that minus tells me I'm going to have different signs. When we get to the next step, we have to have one plus and one minus factor. Now what we want is the middle term. We want a plus 19x. And so what we're going to do is we're going to factor all the ways to factor 20. So we got 1x and 20x, 2x and 10x, 3 doesn't go into it, 4x and 5x, and then 5's on our list. So those are the possibilities. All right. So how do we add or subtract these to get a positive 19x? Well, we need -1 plus 20. Now you could do 20x minus 1x. What I would actually, if this is me, since I've been doing this for a while, if these signs are different, which is what we expect, right? To get that -4, the signs have to be different. If you put that negative in your second one, then you have to deal with the negative in the AC method. So I would probably do -1x plus 20x to avoid that, but for purposes of review, let me do it that way. So remember that the whole reason we're doing this AC method is the next step. So we're going to take that and replace the 19x with those two terms. And now we have 5x squared plus 20x minus 1x minus 4. And so how does that help us? Well, now we have a 4-term polynomial, which means we're going to do factor by grouping. So if you're a factor by grouping fan, then you tend to use the AC method a lot more. Remember, for factor by grouping, we're going to group the first two and last two, look for GCFs. GCF in the first two, 5 and an x. If we divide both of those by 5x, well, 5x squared divided by 5x, it's just 1x. And then 20 divided by 5 is 4. And then x is canceled. Now here's where you have to be careful. What's the GCF in the last two? Well, if you're looking at it and thinking none, remember, we always have to have a GCF. So there is a GCF of 1. Sorry, I'm about ready to sneeze. I'm trying not to sneeze. The other thing you have to watch out for factor by grouping is if that middle sign is negative, we do need to factor out, whatever that sign is, bring it down. So if it's positive, it's a positive GCF. That middle term is negative, you have a negative GCF. Okay, and so what do we get when we divide both of these by -1? Well, divided by -1 changes the signs. So we have a positive x and a positive 4. And remember, at this point, if these are not the same, something is wrong. You got to figure out why they're not the same. The most common mistake at this point is people would have x minus 4 because you factored out the negative of the first one, but not the second one. But if you distribute it, and that was a -4, we'd have negative times negative, which is positive. Right? So if these are not the same, it's almost always like right here where the mistake is. And then once they're the same, then we go straight to the answer. So our answer is 2 binomials. One binomial is what's inside the parentheses, and then the other one is what's outside the parentheses. So x plus 4 times 5x minus 1, or flip-flop them. Some people like 5x minus 1 first. Doesn't really matter. All right, but it's, you're going to have a trinomial with a 1 in front of the squared term. You're going to have a trinomial that doesn't have a 1 in front of it. you're gonna have to be able to deal with both on the test. You could use same method for both, or like I did here, different methods, whatever works for you. But I can guarantee you, you're gonna be doing these on the test. All right. Let's go back. Quiz. Okay. Again, if you're slowing down, reading the instructions, right there in the instructions, it says factor the difference of two squares. Like you're going to have to do every single. I feel like I don't have enough factoring problems in here. Let's see. The 25x squared minus 49. And so hopefully you've went back and looked at how to do all your factoring techniques. So for difference of squares, one, it's a binomial. Two, it's a difference. And then three, is it something squared minus something squared? If you can find what's being squared, then we can go from there. Well, how do you get 25x squared? Well, 5 times 5, x times x. What do you square? Get 49, 7. So this is a difference of squares. Now we can factor it. So what's the pattern for difference of squares? What are our two binomials? Well, to get 25x squared, that's why this is the important part right here. So how do you get 25x squared? It's 5x and 5x. How do you get 49? It's 7 and 7. And then what do the signs have to be? Well, to get a negative 49, 1 plus, 1 minus. Right. I don't know if you, from online classes, if you feel like the disconnect with that week of weather. I know my in-person classes, it felt almost like we were starting the semester over because we weren't on campus the whole week. If you were at home, stuck at home, that didn't have hopefully the same impact. But please make sure you go back and review your factoring before this test. Let's go back to. Okay. So notice that we've now done all of our techniques. We've done GCF, we've done factor by grouping, we've done a couple trinomials, we did difference of squares, and now look at this problem. So you're going to have y to the fourth plus 11y cubed plus 28y squared. And it says factor completely. And this is what I was talking about is the messiest factoring is going to be after you do all the techniques. I'm not going to work all the way through this one, but let's talk about how to get started. This is my number 14. Fourth. So when I see this, the first thing that jumps out at me is the fact that I've got exponents bigger than 2. When I have exponents bigger than 2, and especially if it's a trinomial, that pretty much tells me this is going to be a GCF problem. Because the messier it is, the more likely it is to have a GCF. Okay. So, and when you look at it, there's a Y in all of them. So there's definitely GCF here. Okay. Now there is no number GCF because there's just a 1. But remember for GCFs, they could either be numbers, they could be variables, or they could be both. In this case, it's just a variable because they all have Y. And remember the smallest exponent. Because this one has 2 y's, this one has more than 2 y's, this one has more than 2 y's, but they all have at least 2 y's. So you factor that out. Especially you're dividing all of these by y squared, which is going to reduce the number of y's by 2. That's going to become y squared plus 11y and then plus 28. And then what you have to do is that, here's sort of the red flag. Which I don't have a red marker, so orange is close as I'm going to get. So the fact that this is squared, that tells me it's probably going to have to factor again. That's not 100% guarantee, like we were doing the homework, but this is on the test. And so I'm for those who watch the video, I'm telling you, this is what this last factoring problem is gonna look like. So what you're gonna have to do is, now that's a trinomial. So like go off to the side, factor that. That one looks a lot like number 7, except now it's plus. And so since everything's plus, I know it's going to be y plus something, y plus something. And since, we've already did this 28, so that's going to be 4 and 7. And then don't forget GCF is part of the final answer. So if you have a trinomial that you're trying to factor as a trinomial and it just feels like it's really messy, then that's a good indication you're missing a GCF. Um, and so I can, even if you're not getting it, I can give you partial credit if I see work. A lot of people on a problem like this will give me the GCF and then ignore the trinomial. And so that means you did half of the factoring, so you get half the credit. But again, half the credit's better than no credit, right? But those points here and there add up, right? And on the test, points matter a lot more than they do in the homework, right? Okay. So those are your factoring problems on this test. So that is the R5. So notice how much time we spent on that. That's why I'm saying this is one of the big components of this test. All right, then we get into some radicals. So there is simplify a cube root with a number and a variable. So make sure you can do your square roots and cube roots on your calculator. If it's not a perfect square or a perfect cube, if you have a graphing calculator, remember graphing calculators won't do the radicals for you, they give you the decimals. So you're going to have to do your factor trees and the grouping method. But if you do the cube root of -8, it is -2. Right? And so the grouping method comes in handy. I'll do this one right quick. This is a short problem. We'll have to go through it. So when we're simplifying this, if you have variables and numbers, I highly recommend that you write it out separately. So make sure that you can do these on your calculator. Like I said, if this wasn't a perfect, if this wasn't a perfect cube, then I would do the factor trees. So 8 is 4 times 2, is 2 times 2 times 2. So the way you would do the grouping method. Now the negative, you can take the negative of a cube root that just tells us our answer is going to be negative. So, if this was a square root, then we'd be dealing with an I situation. Or, yeah, I don't think I think if we give you a negative square root, it's going to be a complex number. So, but we can take the negative root of a cube. So 8 is 2 times 2 times 2. So remember, for the grouping method, since we're doing cube root, we're looking for triplets. If this was a square root, we'd be looking for pairs. So we have one triplet. So that means we pull out 1, 2. And then there are no 2's left over, so there'll be nothing inside the radical. For the variables, it's nice because you don't have to do the factor tree, just write it out. And so now we're doing cube root again, so we're looking for triplets. So there is one group of 3. So that one group says I pull x to the first out. If there were 2 full groups, I'd have x squared. If there were 3 full groups, I'd have x cubed. But there's only one group of 3, so there's x to the first. And then left over, we have 2 x's. So we'd have the cube root of x squared. It's what's inside. Then our final answer is -2 x cube root of x squared. So you're definitely gonna have a problem like this. Probably maybe a little bit messier. Like it could have an x and a y. Here. So you have the 4th root of 512, x to the 9th, y to the 12th. So this is where, if I do the, again, make sure that you can use your calculator. It is part of what you can have for this. So whatever calculator you're using, make sure you know how to use it. The 4th root of 512. All right, so I'm getting a decimal number. So that means, the calculator for square roots will give us, like if we did say the square root 512, it'll give you like the radical, the simplified version. If it's a cube root, 4th root doesn't do that, so we're going to have to do some factor trees. This one's a little bit messy because of the big number. So let's go through this. All right. So again, split it up. I want the 4th root of 512, the 4th root of x to the 9th, and the 4th root of x to the y to the 12th. So for 512, well, if you're going to start by 2, if you see something bigger, then definitely want to start something bigger because dividing by 2 could take a while. All right, but eventually, I think I'm just going to keep dividing by 2, so 128. 128 divided by 2 is 64. Well, here, I know 64 is 8 times 8, so I can save a little bit of lines. And then 8 is 3 2s. The random number generator made this one a bit messy because that's a lot of 2s. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This one feels a little bit messy for a test. I would prefer like a square root with a smaller number. So sometimes in these practice problems, I put a little bit messier problems. But now how do you do the grouping method? Now this is a 4th root, so remember now we're looking for groups of 4. One group of 4, 2 groups of 4. So we bring 2 2s out, and then there's 1 2 left on the inside. And then 2 times 2 is 4. Gives a 4th root of 2. Do the same with 9, or sorry, x to the 9th. There are 2 pairs of 4x's with 1 left over. So 2x's makes x squared, and the 4th root of x. Now you could write out 12 y's. This is where one of the shortcuts we talked about with the division method. If you remember, we can write fraction. You could write this all out, do grouping method. But the shortcut is you could rewrite this as a fractional exponent. If you remember, the index is the bottom of the fraction. The number on the exponent on the inside is the top. So the 4th root of y to the 12th is the same as y to the 12 over 4th power. And 12 over 4 is 3 with no remainder. If you're going to do this, you want to do this as a long division, because if you get a remainder, then that's going to tell you what's going to be on the inside. If you get a whole number, that's what's on the outside. So this is a messy version of this problem. Inside we have 2 index. So this is a little messy for a test, but if I made that square root and made the 512 smaller, then this would be fair game. The only difference would be if it's a square root, we'd be looking for pairs instead of groups of 4. You're definitely going to have to simplify something along these lines with both variables and numbers. So so when it comes to the roots and radicals, to me, good test questions are definitely got to simplify, and then you're going to have a multiply problem. It could be just a binomial or a monomial times a monomial, or it could be a FOIL problem. But how do you multiply radicals? Remember, you multiply what's outside with outside, and then what's inside with inside. Do not mix them. Okay, so that would be 4 times 5, so it'd be 20 on the outside. And then whatever the square root of what is 35 times 7. 35 times 7 is 245. So you'd have 20 times the square root of 245. And then that gets kind of messy. So to me, that is an excellent spot to use the calculator. So like, yes, you could do this in a calculator all at once. Here's how I would like to see this on the test so that I can give you partial credit if you miss it. So what I would like to see is this, that you show me that you know that you do outside with outside, and then that, which I guess technically you did that on the calculator as well, but then if you do that on the calculator, I don't expect all this for square roots, but you can do 20 square root, square root, square root. I copied it incorrectly. 245. And so, yep. Now see, that's a big number. So let me take the 20 off. Just do 245. All right. Yeah, so what that is that's 20 times 7 times square root of 5. So now 20 times 7 is 40. All right. So if these numbers get too big, you want square roots, you're gonna get decimals, but notice that I just took off the 20 and focused on the square root. Okay, if that didn't work, then back to factor trees if you want full credit. All right. Yeah, and I am aware that MATLAB is doing random number generator stuff. So occasionally when it does random number generators, the numbers are bigger than I kind of expected. And so sometimes that makes those problems harder. And so when that's the case, if you're showing me work and don't get the right answer, I tend to be a little bit more lenient on the partial credit. So it's like I said, I am much more worried about the process than I am the exact answer. All right. There should have been a FOIL problem. That one was, I guess there's a potential test question that's not there. So if that was like, well, I mean, it would FOIL it, and then you're multiplying just like you are here. Yeah. All right, and then you get into 1.1, solving equations. Having variables on both sides, this and numbers on both sides, this is like the core equation that you got to be able to solve for algebra. We're not going to get you, we're not going to be any smaller equations to start you with. This would be like the smallest. Yeah. So those are kind of the warm up. You're definitely going to have a question like number 20. Right? And so what are you going to do first on 20? Well, you're going to distribute the 4, you're going to distribute the -3, and then you're going to have some like terms to combine on the left-hand side. And then once you do that, then you can solve your equation. Same thing here, except now you got -2 to distribute both times, and then go from there. Great. What is the first step on solving this equation with fractions? Dun, dun, dun. I know everybody loves fractions, so let's work through this one. All right. So hopefully you remember clearing the denominator. You're going to multiply everything by the LCD. So what is the LCD? Oh, and the other, make sure to if you have something that's a whole number, put it over one, please. Because I find that students that don't put that over one tend to make more mistakes on this problem because they tend to forget to multiply that by the LCD. But every single term has to get multiplied by the LCD. So always start with the biggest denominator. Very often it is that biggest denominator. If not, it's going to be a multiple of that. But 2 goes into 8, 1 goes into 8, so 8 is the LCD. If 8 didn't work, like say this was a 3, then you'd be looking at 8 times 2 is 16, but 3 doesn't go into 16. 8 times 3 is 24, and then 3 and 8 would both go into 24, so then it would have been 24. But always start with your biggest denominator, and if you need to, start doing multiples of that. And now you're going to multiply every single term by 8, or specifically 8 over 1, because they're all fractions. So 8 over 1 times 1/2 x minus 3 over 1, 8 over 1 equals 8 over 1 times 5/8 x. And if you've done this correctly, once you simplify it, then our fraction should go away because all the denominators should be 1. Whether you simplify first or multiply first, then simplify, it's up to you. But I see 2 goes into 8 4 times. Then I have 4 times 1 times x, so that would be 4x, or 8 over 2, x is 4x. And then those are just 3 times 8 is 24. And on this last one, 8 divided by 8 cancels, and you're left with 5x. So if you multiply every single term by the LCD, you're going to get and you do it correctly, you're going to get an equation without fractions. Now, once you do that, now we're back to regular solving. You could get the variable to the left. And if that works for you, doing it that way all the time, then by all means do so. For this one, since there's no constant on the right, I would say leave the 24 over here and move the 4x over. We're going to subtract 4x from both sides. So you get minus 24 plus 1x or just x. Oh, so we're done. If you did subtract the 5x over, you'd have to make sure to add the 24 over to get the 24 over to the other side. So that way you're isolating your variable on one side and you're constant on the other. But just like those problems where you had to distribute and combine like terms, once you do that, then you're back to like this level, or like having numbers and constants on both sides, or numbers and variables on both sides. So this is, like I said, this is the core equation you got to be able to solve. It's just some of the messy ones have extra steps to get there. Definitely got to see this or something very close to it on the test. Same idea. So like here, the LCD, I would start with 4, but 3 does not go into 4. And so then I start doing multiples of 4. Well, 4 times 2 is 8. 3 doesn't go into 8. Next multiple is 12. Well, 3 goes into 12 because 4 times 3 is 12. Okay. So I would multiply everything here by 12 over 1. All right, what is the first step here? Clearing the denominator theoretically could work, but that's a bit messy on this one and unneeded. Because this is a proportion. Because it's a fraction equals a fraction. I'm not going to work through this whole thing. I'm just going to work through the first step. Because once you do the first step, then you're right back to a normal equation. So if you have a fraction equals a fraction, you're trying to solve for it, what is the first step? All right, hopefully you're saying cross product, cross multiply. And what do you have to be careful of in this case, because those are binomials? is it's 5 times the entire thing. So it is, sorry, it's 5 times the entire x over 2 or x plus 2. So you've got to use parentheses. And then we have equals, and then we have 3x minus 4 times 2. We tend to put the 2 in front. So both of these are distributions. The first thing you would do, or the next thing you would do, is do your distribution. But by doing that cross product, it takes an equation that has a fraction on both sides, gives us an equation without fractions. So that would be 5x plus 10 equals 6x minus 8. And then from there, I'm just going to say and solve. Because that makes it, that's a core equation. You've got to be able to solve for this test. But the first step on that proportion is doing your cross product. Or cross multiply, whichever way you prefer. All right. Then we get into formulas. So you're going to have two types of formulas. Let me see, go through here. Do we give you any numbers to plug in? All right. Now, normally we have numbers plug in too. I'm not seeing these on the practice test. I wonder if I took those out of the actual test. Because one of the problems with this first unit, there are so many different types of problems. I could probably make this a 40 question test if I covered everything, but I'm not. But that's just too long, right? So we're kind of hitting the highlights on some of these. So let's do this one. We get P equals 5n plus 5u. We're going to solve for n. So here is my tip if you're feeling a little uncomfortable or a little lost with these formulas still. We are still solving equations. It's just the only difference between this and solving for x is it's not x. So one of the things that you can do if you get stuck, ask yourself, if I was solving for x, what would I do next? A lot of times I find that helps. Now what I would like to do is we're solving for n. So n is what we're trying to isolate. So I like to circle it because that tells me that is what I'm going for. And so if that's what I'm trying to isolate, that 5 has to move and that 5u has to move. Okay, the p is good because it's on the other side. So I'm not going to move the p. I'm just moving the 5 and the 5u. Now, which one do we do first? Well, if that was 5x, what would you do with the 5? We'd be dividing, right? And remember, if we're dividing, that should be the last step. So when we're solving equations, moving stuff across, we're doing add or subtract first. So we're going to deal with that 5u first. When we subtract 5u, it moves to 0. We'll do to one side, we got to do the other. Now, those are unlike terms, so don't do anything with them because you can't, right? Because they're unlike terms. So you have p minus 5u equals 5n, and now we can divide by 5. And then once you get your variable, stop. Don't try to simplify that anymore, because then you can just start introducing mistakes. But once you get your variable isolated, that's good enough for me. The only time you would do anything more if we were solving for y and it said slope-intercept form, then we're getting that y equals mx plus b that kind of got briefly mentioned. We're going to see that a lot more in unit 2. If this was y and x, then we would divide by both of these by 5. Right. So you could do that and then say that's p over 5 minus u. That would be acceptable. And that's what we're going to do with the y equals mx plus b. But for this test, the formulas, once you get there, get done. And like I said, at the beginning, circle that variable you're trying to solve for. That kind of highlights, and hopefully in your brain, like everything else has to move. But if you get stuck, ask yourself, if this is x, how would I solve for x? And go from there. Find what that is. All right. You're definitely going to have a formula like this to solve on the test. Like I said, that's so from 1.1, you're going to have probably like a basic equation. You're going to have like an equation with like some distribution and some combined like terms on one side to do. You're going to have an equation with fractions. You're going to have a proportion. You're going to have a formula. So that's like, you know, the only, if I had to, I mean, that's why I couldn't add any more. And if I did cut something out, it'd probably be like the basic equation because like the longer equations will work back to the basic equations. All right, so that's the second big topic for this test is 1.1. Oh, and this is where like you'll notice they have capital letters in this one. MATLAB is extremely picky about that. Uh, like if you did the lowercase letters and all this, at most I would take off 1 point. I'm not near as picky about that as MATLAB is. All right, so then we get into complex numbers. So anything on the test, if you see a square root of a negative number, I has to be part of your answer. All right, and so the negative on the outside just says the answer is going to be negative. I need an I. And so if I take out the I, then I'm doing square root of 4. Square root of 4 is 2. That would be negative 2I. So that's like the main reason we did R8 is so that you could simplify a square root of a negative number. If you have to add or subtract these, this is just like with X. There is no difference really. There's nothing to distribute for the first one, so you can drop those parentheses. This has a negative distribute, so that'd be -4 and then plus 5i. And then once you do that, then you just combine your like terms, just like I said, just like their X's. There's another add or subtract. All right, now if you're foiling, the one thing you have to be careful of, this for the most part works just like X, but on this last part where you have the negative 2i times I gives you -2i squared, don't forget that you have to replace I squared with -1. Once you replace I squared with -1, then it's just, that would be, see, -2 times -1 would be +2, and then you combine like terms. But this is a FOIL, just like if that was -2, 8 minus 2x and 3 plus x, with the one additional step that I squared has to be replaced with -1 if you want to get full credit. That's what we did with complex numbers. All right. So then we get into solve quadratic equations. Now we're solving these with x squared. All right. So to solve by quadratic equations is either solve by factoring, solve by square root property, or the quadratic formula. Now this one specifically says solve equation by factoring. Okay. Does that mean you have to factor? No, and the reason being is the quadratic formula can solve any of these. So, like, ideally you could factor it, but this is a messy factor, right? Because it has that 7 in front of the x squared, that 48 is kind of big. And so this is one where on the test, when you get to these quadratic equations, take a few moments to see if you can factor it or if you can do the square root property. If you can, then that's going to save you probably some time because the quadratic formula, even though it is, I guess, a straightforward in its application, there are a lot of steps, so it can take a little bit of time. If you can see how to factor or do the square property, that tends to be quicker. But this one, take a few seconds. If you don't see how to factor it, just do the quadratic formula. And for both solve by factoring and the quadratic formula, what's the first step? Make sure it's equal to 0. Okay, if it's equal to 0, then go for it. I'm gonna skip this one and I could do the quadratic formula on this one, but it's gonna come out with some like I want to try to get some some imaginary solutions, so I'm gonna skip down a little bit, but um, it'll all work out the same. Okay. Like on this one, solved by factoring. Okay. If you see that that's a difference of squares, and you can factor that to x plus 9, x minus 9, then bam, all you gotta do is set each one equal to 0, and that can be quick. If you don't see how to factor it, you might look at that and say, well, there's no x term, so this is a square root problem. So you can add 81 to both sides and then take the square root of both sides and do your plus or minus and get two answers that way. Or if neither of those work for you, you can do the quadratic formula. What do you have to be careful of? Well, a is 1, because there's 1x squared. What is b? Well, b is not negative 81 because b is your x coefficient. There is no x in this problem, so b would be 0. And then c would be negative 81. So you can still do the quadratic formula on this. You just got to know that b is going to be 0. Oh, and like this one, this is about as you can't get any more set up for a square root method problem. All right, because it's already got the square term by itself. You just take the square root of both sides. A third of the class, even though I'm warning you, a third of the class is going to get half credit on this one because you're not going to do the plus or minus. Right? If you forget the plus or minus, you're only giving me one solution, not two. So you've only done half the problem. So if you are taking square root of both sides, please remember your plus or minus. All right. Let's see, do I want to do that one? Let's do this one. All right. All right, so we got x squared minus 4x plus 53. So it's equal to 0. Again, if it's not equal to 0, then get everything to one side. In the long run, it doesn't matter, but my recommendation is take it to whatever side gives your x squared positive, just because it works out better that way usually. Yeah, but let's work through this one. All right, so the first thing I would do is can this factor? So like what's going to multiply to give me 3? That's going to add or subtract to give me 4. Turns out nothing because 53 is prime. Okay, so this one's definitely not going to factor. All right, and so don't try to force it to factor. Just like I said, you can take a little bit of time, but if it, and the ones that are going to factor are going to be like the first couple. This is after the square root property, and it's talking about in the complex number system in the problem. So if it's talking about that, then it's probably not going to factor. All right, so since it's equal to 0, A is 1, B is negative 4, C is 53. And if you followed my advice and like before you started the rest of the problem, you data dump this on your paper, you're going to have the quadratic formula. Now I just plug everything in. The negative B that's a double negative, plus or minus. And again, please use parentheses when you're plugging in these numbers, particularly negative numbers. If not, that's an extremely common source of mistake. So 4 times A times C, so 4 times 1 times 53, all over 2 times A, just 2 times 1. Okay. So now clean it up. So double negative goes to positive 4. Now at this point, if you want to do like inside the radical all at once, I'm okay with that. I still tend to do, negative 4 times negative 4 is positive 16, and negative 4 times 53. Minus 212. But if you want to do like all this all at once, but don't do the radical, just do inside the radical on your calculator if you're doing it by steps. So 196. And it is negative. So that's the first part of simplifying your quadratic formula, is dealing with that negative out here, dealing with that square root, and then 2 times whatever A is. And now what is the square root of 196? Big numbers, put in the calculator. All right, so we're getting a domain error. So what does that mean? Well, that means we have a complex number because the square root of a negative, right? So before plus or minus, there's going to be an I involved. So you have to know to take that negative outside the square root. The square root of 196 is 14. So that'd be 14I. All right. So now, how do we simplify this? That I wasn't there, my recommendation would be to split this up into the plus or minus and like 14, 4 plus 14 over 2, 4 minus 14 over 2. So for real numbers, that's what I would do. If this is an I, or there's still a radical left, because it's not a perfect square, then what you need to do, or my recommendation, is look for a GCF in all three. It's either you divide all three of these by something or nothing. It's all or nothing with those. Not, you don't just divide, either the 4 by 2 or the 14 by 2. It's all three or nothing. So there's a GCF of 2 here. So I'm going to divide all three of those by 2. Be 2 plus or minus 7i over 1, or 2 plus or minus 7i. And then MATLAB doesn't have a plus or minus button. So you have to write that as 2 plus 7i, comma, 2 minus 7i. With everything they can do, I'm kind of surprised at this day and age they still don't have a plus or minus button. And like I said, if this was a radical, like let's say that this had been 4 plus or minus, I don't know, 8 squared is 3. Must be 6. 8 squared is 6 over 2. So how would you simplify that? Well, one, do not divide what's inside the radical with something outside. That square root of 6 is simplified it's going to get, so that's not going to change. But you're still, I should make this even messier. Let's do that as a 12, right? And so what do they all have in common? Well, there's a GCF of 4 here. So divide all three of those by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. Then the square root of 6 tags along. And then 12 divided by 4 is 3. And then that's how you simplify it. And then you have to split it up, 1 with a plus and then 1 with a minus. So when it comes to the quadratic formula problems, every single quadratic equation can be solved with quadratic form. May not be the quickest if you can factor and do the square root property, but they can all be solved with quadratic form. Step 1, make sure it's equal to 0. Step 2, get the right A, B, and C, plug it in. Next step, do the simplifying, the negative out here inside the square root. Then once you get down to that, simplify inside your square root. And then once you simplify inside the square root, look for a GCF in those 3 terms. That is quadratic formula. My voice is starting to go a little bit, but we're getting. So I may not work through too many more problems, but we'll at least talk through these. So that is 1, 2, 1, 3. And now looking here, we have the find the real solutions. This is a radical equation. So when you're solving radical equations, obviously the messy part is that x is on the inside of the square root. So how do we solve this? Well, the first step is isolate that square root by itself. So in this case, it's already isolated. But if there had been like, say, a -7 outside the square root, then before we did anything else, we'd have to add 7 to both sides. Okay. Now, once it's isolated, square both sides. Because what's the opposite of a square root? It's squared. And so on this left-hand side, square root squared cancel out. And you're left with 6x minus 2. On the right-hand side, you're just squaring 4, and so you get 16, and then you have an equation to solve. We don't need plus or minus because when you're squaring something, it's always positive. It's when you're going backwards with the square root that you need to do the plus or minus. Now, the one extra thing that people tend to forget on the test is with these radical equations, you always have to check your answer in the original problem, because sometimes we get what we call extraneous answers. So let's say that we get, I don't know, x equals 2. Make sure to plug x equals 2 back in the original problem, see if it works. If it doesn't work and it's your only solution, then no real solution is a possibility. If you happen to, if you are solving this radical equation and you get an x squared equation, and you end up getting 2 answers, check both answers, because it could be that one of them works You know, it doesn't, could be that both of them work. It could be neither of them work. That's a little bit harder, but usually at least one of them works. But if you do have two answers, check them both. I don't know if we get that messy. Yeah, so like this one, well, this one looks messy because like this x plus 4, you're gonna have to write that out twice and FOIL it out. But on this left-hand side, when you square that square root, you're gonna have just x squared minus x minus 9. So that x squared on this left side is gonna cancel out the x squared on the right side. So that would be like the messy version of that. So you're definitely gonna have one kind of basic, right? Like one 37 or 38, and then you might have one like this. All right, and then the very last thing on the test is solving your inequalities. So for your inequalities, one, know how to solve them. The solving process works exactly the same as solving equations. The only difference is at the very end, if you divide by a negative, make sure to flip your inequality. So if that had been a -6, in the end, that greater than would have become less than. The solution, when it says type in interval notation, they want the x and the greater than or less than, right? Don't just put the number, put the actual inequality. Now, here's since we're doing this video here, sometimes you can kind of cheat if you have multiple choice. Notice that every single one of these, and these are tidbits I only give for the people who are watching the videos. Does every single one of these has a 4 as a starting point? So I can tell you right now, that's going to be 4. And since I didn't have to flip the inequality because I divided by a +6, it's still going to stay x is greater than 4. All right. So that is what they're looking for the interval notation. Or sorry, yeah. Oh, wait. Ooh. See, I got ahead of myself. That's what happens when you get in a hurry, right? So interval notation is what I typed interval notation. No, that's inequality notation because it has an inequality. So I can tell you now that x greater than 4 is let's just, I'm going to work through this one. Sorry about that. That's what happens when I've been doing this for years, and if I get in a hurry, I make mistakes too. So number 40, 6x minus 5 is greater than 19. So we're going to solve this. So normal solving process for isolating x. If you have a choice, I would generally get the variable to the left on these inequalities. That way you're reading it in the proper direction to help with the graph. And then divide by 6. But yes, we do get x is greater than 4. Like I said, this is the inequality notation. But make sure you're reading the instructions on what they want entered. Now, if they want the interval notation, my suggestion is graph it first because then the interval notation follows directly from the graph. And so for the graph, okay, so now we've talked about open circle and closed circle, I think, in the notes, but I think this book has updated everything so it's parentheses or brackets on the graphs. So if it's greater than, okay, so we're starting at 4. Do we use parentheses or brackets? Well, we use parentheses because there's no, and then greater than goes to the right. So that's what the graph looks like. So for the interval notation, we said I would do the graph first. The interval notation says how far left, how far right. I don't know. For my brain, I'm a visual person, so that's why I like the graph for this. Well, how far left? We went to 4, and we used a parentheses, so use parentheses there. Then went to the right, we went to infinity. Make sure you're always using parentheses with positive and negative infinity. If it had been x is less than 4, but the other way, we would have started with negative infinity out here and then went up to 4. Right, so that's something to watch out for. And like, if you're not for sure on the test, then this is like write all the way down on your paper, and then you may not get all credit, but you'll get most of it. Like, because I think a lot of people here would do like I started doing, just put the X greater than 4, but Math Lab's not asking for it in this particular problem. Why it's important to read the instructions. All right, so on this one, and again, this is stuff you've seen in the homework, you've seen in the quiz, but if you haven't been paying attention to the instructions, this might, on the test, when you're stressed, this might get a bit, you're like, what do you do? When it says set notation, see that the curly brackets of the X and the vertical bar, that's the set notation. What you do here, like, that's where, if they talk about set notation, inside is where you put your inequality. Like if we were doing the last, this is not the same answer, but if we've been doing that before, that's what they would be looking. If it says in set notation, put your inequality inside there, put the top answer. The inner notation, again, for inner notation, I personally like to go down and do the graph first, and then whatever your graph is, that will help you do what's the left or what's to the right. It's either gonna be 4 or 6, depending on those options. There you go. All right, so these are the same questions. It's just this one, they don't want, here they wanted, let's see, parentheses for infinity instead of the inequality. And then the very last question on the test is going to be a compound inequality. And so how do you solve a compound inequality with the 3 pieces? Now your goal is to get X in the middle. And whatever you do to the middle, do to all 3 sides. Now, just because this is 0 doesn't mean it's nothing. There is a left side here. So the first thing we would do is add 8 to the left, 8 to the middle, 8 to the right. So 8 plus 0 would be 8. Then that would be 2x. 8 plus 8 is 16. And then the last thing to do is divide everything by 2. So divide the left by 2, the middle by 2, the right by 2. And then when they talk about this in set notation, well, you're going to have compound inequality. So let's see, 8 divided by 2 is 4. And then we want less than or equal to, which is in our button palette. X is going to be in the middle. Another less than or equal to, let's see, that was 8 plus 8 is 16 divided by 2. So when we're talking about set notation, your answer is going to look something like this for a compound inequality, because you're going to have 2 inequalities. There's no less thans in here. Sorry, greater thans. They're always less thans. And it could be like this one has an equals and this doesn't. Or neither of them have equals. Just like whatever the equals are situation here, match that in here. And then the interval notation, again, I like to graph it. We're between 4 and 8. With equals, that would be that. Then on the left, we have 4. On the right, we have 8. Brackets on both. And this is where, like, if you mess up like your graph, but your interval notation matches your graph or vice versa, that's what I give you call like ECF, error carried forward. So I'd like take off for one of them, but I wouldn't take off for both, because you gave me, like, if you put parentheses here, where is it? If you did this one, because you picked A, well, notice that, you gave me the same numbers, you gave me the same bracket. So I would only take off for one of these, not both, because one follows from the other, depending on what order you do it. All right. So hopefully this helps. Like I said, please, when you're doing this, write as much work as you can out on your paper. And then when you're done with your test, put your name on each paper, number each page. And it also helps if you like circle your answers, and like write what number it is. If you want me to look for partial credit, make it easier for me to find your credit, your work. Um, I'm human. I got a lot of tests to grade. If I have to hunt for work, and this is like in your like test, like the test 20 I've graded for that day, I may not be as diligent as searching for your work if it's hard to find. And paper's cheap compared to what you're spending on college. So don't try to do like your whole test on one sheet of paper. Write it out, and then, like I said, take pictures and email it to me. And so, like if you do that, the grade that Math Lab will show you is like your minimum. Right? And then I'll go through and then see if you get, and it's not extra credit, it's partial credit. All right, hopefully this helps. As always, if you have any questions, send me an email. And hopefully, if you're taking it home, you've done your honor lock practice quiz, so you know if that's working for you. If not, get that done so we can get those situations done before you take the test. All right, that's all I have. Have a good day.